The question is, a duopoly faces the market inverse demand function as P is equal to 120 minus Q, where P is the unit price of good being sold by firms A and B, and Q is the total output. Firm A has a marginal cost of $20, which is exactly half of firm B's constant marginal cost. There is no fixed cost for both the firms. If there exists a Cournot Nash equilibrium, we need to find out the value of Q, that is total output in this market. Okay, uh, so this is our inverse demand function that is being given. Marginal cost of firm A, I am writing in place of A and B as 1 and 2 for the sake of simplicity. So marginal cost of firm 1 will be 20, which is being given us, and we are being told it is exactly half of the marginal cost of firm second, that is firm B. That means firm second will have twice the marginal cost of firm A, so MC2 will be equal to 40. Given this inverse demand function, Q denotes the total output. Okay, let us rewrite it. That is P will be equal to 120 minus, since Q is the total output, we can write it in this fashion: Q1, that is output of firm 1, plus Q2, output of firm 2. That means Q1 plus Q2 will add up to Q. Since we have two firms, so this is a duopoly model, and we have the Cournot, problem here. To solve for Cournot Nash equilibrium, we need to find out the response functions of each firm, that is best response function of each firm. How do we find the best response function of each firm? Let us first calculate the best response function of firm 1, okay, which is firm A. So first we need to find out the total revenue of firm 1. Let's denote it by TR. That will be equal to P into Q1. So our P is this 120 minus Q1 minus Q2. To this we multiply Q1. So this becomes 120 Q1 minus Q1 square minus Q1 Q2. This is total revenue of firm 1, the function rather. What is marginal revenue? Marginal revenue of firm 1 will be the derivative of this total revenue function with respect to output, that is with respect to Q1, that is dTR1 with respect to Q1. We take derivative of this function partially with respect to Q1, so we will get 120 minus twice Q1 minus Q2. So this is our marginal revenue. Next we need to find out the marginal cost that is being given us. Now equilibrium requires our marginal revenue 1 should be equal to marginal cost 1. That means marginal revenue of firm 1 should be equal to marginal cost of firm 1. Marginal revenue we calculated, it is 120 minus twice Q1 minus Q2. It should be equal to marginal cost, which is being given us as 20. So this becomes 100. If I transpose it here, 100, and let's transpose it here. So we will get Q2 is equal to twice Q1. Solving for Q1, Q1 will be equal to 50 minus 1 half of Q2. This is the best response function of firm 1. By best response by best response function, what we mean, it is the best response of firm 1 in terms of output level decided by firm 2. How firm 1 reacts in terms of output? When firm 2 has set the output as Q2, or it simply tells us optimal quantity firm 1 should produce given firm 2 produces Q2. Okay, symmetrically we need to find out the BR2, that means best response function of firm 2. Again same method. First we need to find out the total revenue of firm 2 will be equal to P into Q2. So P inverse demand function is 120 minus Q1 minus Q2. To this we multiply Q2, that gives us 120 Q2 minus Q1 Q2 minus Q2 square. This is our total revenue function of firm 2. Now what will be the Marner revenue? Marner revenue of firm 2 will be the derivative of, that is partial derivative of total revenue function of firm 2 with respect to Q2. So we have here 120 minus derivative of Q2 is 1, Q1 minus twice Q2. Again, at equilibrium, Marner revenue of firm 2 should be equal to marginal cost of firm 2. So this implies 120 minus Q1 minus 2Q2 should be equal to, the marginal cost of firm 2 is 40. So 120 minus 40 is 80 minus Q1 is equal to twice Q2, transposing this here, or Q2 will be equal to, so it is 40 minus 1 upon 2 Q1. I hope I am doing it correctly. So mistakes happen. I apologize for that very stuff. It is, inevitable. So this is the best response function of firm 2. Simply the optimal quantity that firm 2 should produce given firm 1 has produced Q1 quantity. This is called the BRF, or reaction function of firm 2. Now Q1 is equal to this, Q2 is equal to this. Simply plug the value of Q2 is equal to this into this function, or the value of Q1 here, it is one and the same thing, to find the Q1 and Q2. So our Q1 will be equal to, we have 50 minus 1 half of, what is Q2? It is 40 minus 1 upon 2 Q1. Solving. So we have Q1 will be equal to 50 minus, it is 20, minus minus is plus, 1 upon 4 Q1, which implies, if I transpose it here, it is Q1 minus Q1 divided by 4, okay, will be equal to 30, which implies, so is it 30? Yes. Okay. So this becomes 4Q1, so this is 3 upon 4, 3 upon 4 Q1 is equal to 30, which implies Q1 will be equal to 30 into, transposing it, it will be 4 upon 3, 3 ones are, 3 tens are, so 10 fours are 40. Q1 will be equal to 40. If Q1 is equal to 40, what will be Q2? Q2 will be equal to, so since Q2 is equal to this stuff, so Q2 is equal to 40 minus 1 upon 2. Q1 we got as 40, which comes out to be 40 minus 20, which comes out to be, so 40 minus, am I doing the calculation right or not? So 40 minus 3 ones are 10 fours are 40. Okay, so Q1 is 40. This is our reaction function, so 40 minus 20, it comes out to be 20. So firm 1 should produce 40 units, firm 2 should produce 20 units. That means Q will be equal to Q1 plus Q2. Total output will be equal to, we have 40 plus 20. That comes out to be 60. The correct answer should be 60.